Let's do one more example where we're supposed to find a value for delta. This is just a little bit different though. I'm given a very boring function, a linear function. The limit is x approaches 2 of minus 2x plus 3. And we know how to evaluate that. The limiting value has to be minus 1 because we have a rule that says when you're dealing with a polynomial, you get to just substitute in. Polynomials are continuous after all. And in this one, I'm just given epsilon's bigger than 0. I'm given no other information. I'm not given a specific value. Well, this is the more important kind of question because limits work when if you give me any number for epsilon, I can tell you a recipe to find delta. And that's what we're supposed to do here. Instead of using a specific value of epsilon, I'm going to use the symbol epsilon and give you a recipe that tells you what delta is for any number epsilon. So we start off the same way. I think that the function minus 2x plus 3 minus L has to be less than some number epsilon. I don't have a specific value to plug in, so I'll just use the symbol epsilon. Well, let's see what happens here. I can get rid of those unnecessary parentheses and I'll have some like terms to deal with. 3 and 1 make 4. And now I can do the trick that always works where I rewrite this statement without the absolute values. Now I need to take 4 away from every side. And let's see. That would give me this inequality, that 2x is between minus 4 minus epsilon and minus 4 plus epsilon. I lost a minus symbol there, that's going to be important. And now I have to do a little division. I have to divide everything by minus 2. Oh, an old inequality rule tells me that when I multiply or divide by a negative number, I have to flip the inequality symbols. All right, so I divide everything by 2. So let's see, minus 4 divided by minus 2 would be 2 plus epsilon over 2 is now the top end of my inequality. And let's see, minus 4 divided by minus 2 is positive 2 minus epsilon over 2. So there's my interval on the x-axis that's supposed to work. If I gave you a specific number for epsilon, we'd have numbers to evaluate there, right? Substituting in. So let's look at that inequality. And again, I like to read those from left to right, from the small numbers to the big numbers. And I actually see the value of delta here. Because what I can imagine on my x-axis, my limit was approaching the real number 2. And the top of my interval is at 2 plus epsilon over 2. The bottom of the interval of x is at work is at 2 minus epsilon over 2. And I realize that the distance between 2 and 2 plus something is, well, the something. And on the other side, the distance between 2 and 2 minus something is also, well, the something on either side. The value of delta that would work is epsilon over 2. So if you give me a number epsilon, I know the recipe to find delta. If you tell me epsilon is 1, then the corresponding number delta is 1 over 2. If you tell me that epsilon's 1,000,000, then the corresponding number delta is 500,000. If you tell me that epsilon is a very tiny restriction, 0.001, then the corresponding number delta is half of that. And I would tell you what number that is, but I don't remember what I just said. But this actually gets to the idea, the actual definition of limit, that every time you give me an epsilon, I can always find delta. If I was going to formally write up a proof that that limit exists, I'd actually have to start with this delta that I just found and prove that it keeps the y's with an epsilon. For this class, all we need to be able to do is find that delta given an epsilon.